Hello, I am talking today about the type 1 and type 2 error. Let me explain with an example. Taking an independent and identical distributed random sample, let's say we have x1, 2, of size 25 and variance equal to 16, we can have the null hypothesis where the mean is less or equal to 100 versus the alternative hypothesis greater than 100. Right? Okay. Usually we get the significant level as an input to obtain the critical region from there. But in this case, we have as an input the critical region, which is the critical region is the set of all the combinations that we have from the random sample such that the mean of this sample is greater or equal to 102. Okay, so if we get a random sample and we obtain that this random sample has a mean, an average greater or equal to 102, we will reject the null hypothesis. So given these critical regions, we want to obtain what is the significance level. Okay, let's recall that the type 1 error is when we groundly reject the null hypothesis, which is the significance level. Right, let's write that here. Type 1 error is groundly reject the null hypothesis, or it is basically the significance level. Okay, so now what? The significance level is the probability that my random sample is within the critical region. Okay, given that the null hypothesis is true. Basically, this is the mathematical way to say type 1 error. For this example, we are going to assume that the random sample is coming from a normal distributed population. So we can write basically this bar as the probability that C, this is coming from the C score, is greater than 102, but we have to normalize it, so we have to remove 100 and divide it by the standard deviation, which is 4, basically is the square root of 16, divided by the square root of 25. And simplifying, we have the probability of C greater than 2.5. And if we want to remove this greater than, we can have this like 1 minus the probability of C less than 2.5. So if we see the distribution, basically we have this, we have the mean, this is my mean. We are assuming that the null hypothesis is 100, right? And everything that is greater than 102 is in the critical region. So what is the probability that a random sample it is inside of this critical region is this part, right? And for that we can basically rewrite that as probability 1 minus the standard normal, the 2.5, which is, we can look here, and 2.5 is, in this part is 0.9938. So it's 1 minus 0.9938, which is equal to 0.0062. Okay? Okay, let's go to the next topic, which is the type 2 error, also call it beta. Okay. Type 2 error, which is also beta here. It is the probability of retain the null hypothesis given that the alternative hypothesis is true. For this example, let's say that the actual mean is 103, right? So we can say that given that the population mean is 103, just for the example, what will be the type 2 error? Then if we plot the distribution where the population distribution where the mean is 103, I am looking here to get all these random samples that fall in this region 102. Everything that is less than 102 basically is something that we will say we don't have enough evidence to reject the null hypothesis, and we will retain the null hypothesis even that the actual population mean is 103. So for that we have that beta is equal to the probability of C. Remember, this C score is because we are assuming that this is normally distributed, just for the example, not necessarily have to be normal, is less than 102 minus 103 divided by 4 divided by 5. And simplifying is probability that C is less than minus 1.25, okay, which is the same to 1 minus the standard normal 1.25, which is 156. Sorry, I missed the 10 here. Is around 10%. Another topic that is important here, is super easy to understand from these two type of errors, is the power. The power is exactly the opposite of type 2 error, is all this region where we reject the hypothesis and actually the alternative hypothesis is true. I mean, it was a good thing. So it is basically 1 minus type 2 error. In this case, this is 1 minus 0.1056, which is equal to 0.8944. Okay, and that is all for today. Thank you.